Okay, let's talk about areas of sectors of circles. So first of all, what is a sector? A sector is kind of like that piece of the pie, this shaded region in our circle is the sector of this circle. So the ratio of the area of a sector to the area of the whole circle, right? Remember the area of that whole circle is pi r squared, is equal to the ratio of the degree measure of the central angle to 360. So the ratio of the area, that's what we're looking at right here in our proportional relationship. It's the ratio of the area of the sector to the whole area of the circle is equal to the degree measure of the central angle x. As we can see here, the central angle is x over 360. So the equation is what we primarily use, which we derive by just multiplying this proportion by pi r squared to get the pi r squared over here. And now we have our area of the sector is equal to x over 360 times pi r squared, where again, the x is the central angle of the circle and our r is our radius. Now, this should look somewhat familiar to a formula that we've done before in our circle unit. Remember, in our circle unit, we talked about that arc length that we did by taking that x over 360 again, because that's the portion of the circle we're talking about. And then in the arc length formula, we multiplied it by 2 pi r, or the circumference of the whole circle. So it's kind of along those same lines because we're still talking about arc length was talking about the distance around the circle in our shaded region, and our area formula here, we're talking about the actual area in the shaded region. So here's our formula, our x over 360 times pi r squared. We're going to jump to the bottom of these notes to examples 5, A, B, and C. So we can look at kind of some just beginner plugging into the formula to start there. Also, our directions tell us to leave it in terms of pi. We're not going to focus on that right now. We're going to really just focus on rounding to the nearest hundredth. So our first example, we have x is equal to, so again, I'm going to write that formula so we just get used to seeing it, x over 360 times pi r squared. In this situation, we know that our x is that central angle, 53 degrees, and our r is the radius, or 4 feet. So plugging into our formula, that's 53 over 360 times pi times 4 squared. Now, this we will just put straight into our calculator, and whenever we do that, we get the area is equal to 7.4, I round to the nearest 10th, round to the nearest 100th, I think is 7.41 feet squared. Now, let's look at our next example. We have a central angle. Our x here in this picture is 148 degrees. So x is equal to 148 degrees, and our radius is 6 meters. So again, we can plug into that area formula. Area is equal to x over 360 times pi times 6 squared. I forgot to put my x, excuse me. That's 148 over 360 times pi 6 squared. When we plug that into our calculator, we get 46.50 is what it rounds to the nearest hundredth. And that's, again, meters squared. So here is our area for that. Sorry, and I think that I did this earlier, so I'm pretty sure it rounded either to 40 or 41. I'm not sure. I plugged it into my calculator earlier. And our last example, now here, we're still looking for the area of the shaded region, but that's not the central angle that we're given. We're given the central angle of the non-shaded region. So we could look and say, well, we know that there's 360 degrees total in the circle. And if we take our 65 degrees from the non-shaded region, then that gives us a central angle of our shaded region is 295 degrees. So here is our x, 295 degrees for the shaded central angle, and our radius is 11 inches. Plugging into our formula, that's x over 360 times pi r squared. So we have 295 over 360 times pi 11 squared. And when we put that into our calculator and round to the nearest hundredth, we get 311.50 inches squared. And that is our basic plugging into the area of a sector formula problem.